All right, looks like we're online. I'm gonna help you work through it. I'm gonna help you work through the Git problem. We'll figure it out. What? We'll figure this out. All right. How are people doing tonight? Horrible traffic, right? Yeah, I think there's something both. There's both a game at the athletic park, and I think there's something at DPAC. So, yes, super extra fun. So I'm going to encourage everyone again, for anyone remote or even if you're here, if you were able to start writing those test cases out that we looked at for the exercises, post up a link to where you have the handwritten ones for that. Today we're going to talk about how you would convert test cases into actual code a little bit. And we're going to do it without using any sort of framework or library that helps us write the code. Whereas normally if you're writing tests, you're going to have some libraries that will help you out. On Saturday, it's probably just going to be more of a workshop for people's questions, since I know some people are going to be gone. And so I don't want to cover any critical new material and have people miss that. So it's more just like, if people have questions, we can work through anything. Probably won't even stream, just more hands-on if people want to do that and get individual help. But then next week, we'll start talking about, as I said, we're not using any libraries or anything to help us with testing. Next week, we'll talk about how to leverage the whole massive JavaScript ecosystem to start making your life a ton easier. And that will include pulling down libraries to help you write tests. And one of the things that I'll do is I'm going to write some of these functions that you're writing tests for, and I'm going to write some buggy versions of them and put them up and have you guys run your tests against them to see what's wrong with the version that I've written. Like what bugs are there versus what it should be doing. But today we're just going to get started with that topic. So get started with unit tests, and we touched on this last time. Does anybody remember what a unit test is, or any details about a unit test?
It's 4 different levels. Usually you start flashing on unit tests at the small level.
Yeah, there you go.
Testing functions and objects?
Yeah, testing's really the smallest piece of your code, which is usually a function or an object, exactly. So unit tests are really small, really focused tests. Important aspects of unit tests is unit tests are also code, at least 98% of the time. The way you do unit testing is by writing more code. And you guys have actually been doing this, I guarantee you. Who, when they're writing out one of the functions that they've been doing for an assignment, has called that function and checked to see if it gave them the expected results, right? Yeah, you better have, or you wouldn't have known it was working. That's a rough version of a unit test. All unit testing is formally is a more formal structure around how to accomplish exactly that, and focusing on testing specific aspects of it. And given that you guys were writing the tests for the code that you were writing to make sure that the code worked correctly, following that same pattern, unit tests are written by programmers almost always by the same person who wrote the code that it's testing. And then this is where we'll get into the new stuff today, and I'm introducing both of these topics at the same time. I could have maybe tried to write some tests first, but I think it'll be easier to show you this workflow by doing both at once. So unit tests can be written at any time when developing, like, oh, we've got some functions and they've been in the product, but we want to write some tests to make sure that they work correctly. You can do that. If it's, they've been there for a year, you can write tests around it, or you can write tests ahead of time. You can write tests even before you write the code that it's testing, and that's called test-driven development. And this is where you should be saying, how can you test code that hasn't been written yet? right? What are you telling me? How in the world am I going to write tests for code that I haven't written? Because that doesn't make sense. So that gets to this other concept that ties in heavily with unit tests. Not everyone follows this model, but I think it's really useful to teach, especially where you guys are at. And I've actually been sort of using it. You'll notice that the patterns that we follow for test-driven development will look very similar to the patterns of development I've been showing you when I work through problems up here. And that is test-driven development. First off, it's not really about testing. It's really about design and development of your code. The reason you do a test-driven development approach is not to write the tests, but because it's going to help you develop your code hopefully more efficiently. And it sounds weird to say that you're going to write more code, but you're going to write code faster as a result of doing that. But that's, once you get in the practice of it and you start thinking that way, that's pretty much what happens. And it's about developing incrementally. And that's why I said this reflects the same stuff that I've been talking about in terms of how you should be doing development. And what I've been doing when showing you stuff is I've been trying to do very small increments of development, piece by piece, as opposed to anything large. So given that, there's really 3 steps to what's known as the test-driven development workflow. And those are, first, you write a failing unit test. So you pick what is pretty much the smallest thing that you can do or want to assert about your code, and you write a test to make sure that your code does that. And literally the first, for example, if you are going to write a function, and we'll work through an example in a minute, your first test might just be that, trying to call that function. And the interesting part about what you have here is it fails because you haven't even written the function yet. Like, it's guaranteed to fail because the code doesn't exist that you want to test. And here's why it's important to do that. I have made this mistake. I literally was just talking about this week at work, where somebody put a comment in a pull request, which is a pull request process is where you're like, hey, I've written some code. Somebody else look over this and make sure that it's good for our product and ready to go. And somebody had a comment of, oh, your test always passes. It basically just checks that true is true. And they were like, what? Oh, I guess it does. Here, let me fix it. Oh, we've got a lot of those tests all over in our code. And I was like, guilty. Yep. 2 years ago in this specific domain, we wrote a bunch of tests around stuff that we had written. And we didn't realize that those tests were pretty much just making sure that true is true. We didn't know that until I changed some code knowing that a test should fail, and the test didn't fail. And I was like, wait, what? What the heck happened? Why didn't my test fail that should have failed, right? And then we dug down into it and realized, oh, all of these tests aren't actually checking what we thought. And that's why it's really, really important to make sure when you're writing unit tests that they fail. You need to make sure that you can cause it to fail, because you might accidentally be testing something that never fails otherwise. Then the next step is you've written a unit test for a tiny, tiny bit of code, and then you want to write the code that makes that unit test pass. You really want this to be the simplest, smallest bit of code that you can write to pass this test. So you'll see some of these that we do at first will look absolutely trivial. And you'll say, well, it's sort of silly to write that bit of code because, that's not really our end goal. However, the point is, once again, that incremental building up of your functionality and building it up, designing it piece by piece. Because the more you think about stuff that way, the easier it's going to be for you to build larger programs. And then after you've written the code that makes your test pass, you've got your passing test. Now your job is to refactor, right? Like, oh, let me clean it up a little bit. Maybe I can clean up the test. Maybe I can clean up the code. Maybe I need to clean up some of my other unit tests. There's a step there, and this is the one that gets glossed over a lot, but this is critical to making this a design practice as opposed to just I'm writing test practice, is you need to stop and say, oh, okay, now I've got all my tests passing again. Can I clean up my code to make it go better? And then, oh dang it, 3 steps. No, the fourth step is just you repeat. So you've got a bunch of test cases that hopefully you've written for these things. And then you're going to keep repeating this, adding in test cases and making sure that you pass each one of them with your code until you feel like you've covered the specification of how this code should work. Now, before we get into the sort of hands-on example that we're going to work through today, are there any questions about this workflow or this process? Nothing yet? All right. So let's work through an example collectively. And we'll work through it up here. And then I originally started saying I was going to work through the sort one, and I realized that one would actually be sort of hard to do using this workflow because I would want to just use the built-in sort, and so all the tests would already pass. So I'd be sort of cheating the fact that I want to make tests fail. So since we don't have a zip method in JavaScript the same way that we have in Python, we'll go back to the zip method that we have. And we created the test cases for these in the last class. Here are the tests that we wrote. Let me refresh this. Oh, shoot, it's down. All right, just a moment. Let me see if I can fix this. Because some of this is, I know that that slide has been updated a little bit. All right, and I added one other one, but we'll probably do more. And these are in the same order that we had there, except for the ones that I put in maybe earlier. And what we'll be doing is just working through how you would do this before you even have a framework to help you write these tests. And then we'll come back and visit this again later after we've talked about pulling in packages and libraries, but we're gonna get started. So one of the first things we know it should do is we know it should return an array. Or, as I said before, we know it should be a function, right? It should be a function that we can call. So I am going to, let me see here. I want to open another window of this to work in. And this one, we'll go to this JavaScript classwork, Git project, and I'm going to create a zip.js file. Don't worry, I'm going to zoom in on this in just a moment. All right. Hopefully that's big enough for people to see. So let's go back and look at this again. It should return an array, or as I said before, we should even have a function to invoke. So let's assume we're going to have what our function will be called. Then we'll call it zip, right? So here's what I'm going to do. I'm going to start writing tests down here. And normally you would probably put these in a separate file than your code, but to make this workflow nicer as we're going through this today, I'm going to have all this stuff living together. Zip file or function should exist. And so literally this test, right now at least, is just going to try and call a zip function. And if we run this, we should have an error, right? That's basically a failing test right there. The zip function should exist. Okay? Now we've got a failing test. What do we have to write to get this to pass? What's the minimal amount that we can do? We've got a zip function, right? That's that key of don't start writing a whole bunch of extra code yet. Don't start doing things you don't need, because that's part of this workflow to do some test-driven development. Sweet, I passed, right? And we could formalize this a little more. We haven't really dealt with error handling in this class too much, but we could make that a little better. You will see me writing examples of throwing errors, and you guys have seen errors. You just saw one right there. But for all of these tests that I'm going to sort of write by hand, I will be throwing an error if something goes wrong. So you'll get to see what that looks like writing some code that would throw an error as well.
When you do that, when you write error handling, sort of write error messages.
Yes.
Say that 95% of the things I come across are unintelligible to me. I haven't been about to Asperger's. I understand how
That itself isn't that easy to read. I mean, it's very, if you really know the language, that's clear. But for everyone else who's like, what the heck? Oh my gosh, look at all this scary stuff that got printed out. I'm terrified. There's a whole bunch of lines of code. Did I tell you guys? Was I telling you guys or someone else? Like, I realized it's the silliest things that can intimidate people. I was working in a project the other day, a new project that I was using from somewhere else. And the functions, like, for example, they had all of the functions were something like this. Like, working function. And so they had these like underscores around them. And I realized, and a lot of times they'll do this like as a way to say, oh, this is a special utility thing, or this is a library, or this isn't something you're calling normally. And it's so silly. I've been a developer for ages. And while I was working with this, I suddenly had this realization, like, I'm scared of calling any function that starts with underscores. Just the fact that it starts different scares me, right? I'm like, oh, I shouldn't be doing this. This is wrong. This is terrible. I mean, honestly feel like saying something that, like, developers, we need to be really careful when we write stuff, because something as simple as that can put someone off from wanting to use it. And I'm an experienced developer, and I realized there's no reason for me to be scared of these things. That's silly. But there it was sort of clicking in my head that sure enough, it does that, right? And so seeing something ugly like this as an error message is probably intimidating at first thought. So it's nice I agree, definitely. Thank you for that point. Writing clear error messages is very, very useful. And in this case, our error messages are really going to be about the test failing. So our error messages should be pretty clear about what the error is. Now this one, I could make this better. I'm just going to leave it sort of trivial for now and move on to some of the more interesting ones. So let's now say should return an array. So here's zip should return an array. So I'm gonna do to test this is, I mean, you guys have already written code that tests different types or other things. Normally you can use type of, like type of hello. I'm gonna need to log that to see it, right? Console log type of hello is a string, but this is misleading because does anybody remember why that won't work for an array? Do you know what the type of an array is? First let's try this. Let's see what happens. Okay, we say string. Now what if we have an array? What is the type of an array? An object, right? So we can't use this to tell if something is, you can't use the type of method to tell if something is an array. Does anybody remember how you check if something's an array? Don't worry about it if you don't. That's the type of thing I would Google, honestly. There's an isArray method on the array object, like the array prototypical object, and that will tell you whether something is an array or not. So if I run that now, it's like true because it is an array, right? All right, so I know what I can test, and I know what I want to check. What I want to check is calling the zip method, right? So let's call zip, and we want whatever it returned to be an array. So I'm going to put an if here and say if this isn't true, so if calling zip does not return an array, I want to throw, and this is this weird syntax for errors, I'm going to throw an error. we're just going to go ahead and put something in that's nice and clear, telling us what went wrong, what we expected. And if it's a little clearer, we'll probably be reusing this anyways. So I'm going to create a variable that we'll reuse for our tests, call it test result. And I'm just going to store the value in that each time. So instead of calling zip right in here, I'll change that to test result. Now I shouldn't have made that change yet. I just broke the sort of red-green refactor, or the, write the test, a failing test, fix the code, then refactor rule. But let's see what we have here. I can't fix the fact that this is going to give me the stack trace for the error, but there's our message. Error zip function should return an array, but it didn't. So we know that we're failing, right?
Did everyone notice what the difference between console.log and spread here?
Yeah, I could have logged something in here. You'll notice it.
Do console log of just that statement and
Console log of just this.
yeah.
Yeah. Let me a really good point of what you're seeing. So I'm going to comment this out, and we're just going to log it. Yeah, you don't get to see that error bit. You don't get to see that something failed. You don't get that stack trace. The error really does something important in the code. And there's control flow around that, which we didn't really talk a lot about. But what it's known as is the control flow that you wrap around error stuff is try catch. And the reason that you do that is because usually, and okay, I should have a little session talking more about this, but this is going to be your crash course on errors and the way that they work. Errors bypass almost all of the other rules of the programming language. Errors don't follow standard rules. So I'm going to, let me put some other stuff here. We finished running, all right. I'm just gonna put this here so it's easy to see. Right, so if we run this, we should see that, and then we say we finished running. Everything's nice and cozy. Now I'm gonna change this for this error. I'm pretty sure this is gonna work the way I expect, but notice something else different here? Besides all this ugly stack trace and stuff?
It doesn't proceed on.
Yes, unless you have some air handling around it, it just keeps booting out of your code before running anything else. It's an eject. It literally is like a boom, I'm abandoning all your code until you tell me how to handle this error. And so as we write more and more tests here, one of the nice things about throwing errors instead of using, say, console logs is, I mean, it's nice and a negative at the same time, but we're going to know immediately when it hits an error because it's going to hit that error and eject out of the code and not run anything else unless we put some handling around it to say, oh, we know how to deal with this. And I can show you a little bit of that later, but that's finish running zip tests. I'll just go ahead and leave that here. I'm going to copy this line. We've got this.
Also, that it provides the line number where it occurred, that :11 after the file name. That's an important distinction as well, so it shows you exactly where it might what you're.
Yep.
And that's really helpful because if you just had a console log, it's not always obvious exactly what.
Right. And usually in your code, you're not throwing an error yourself. Usually an error happens because something went wrong in the language and it did it. So unlike this, where you know where the error came from sort of anyways, because it told you, a lot of times you'll have an error, you know, like our earlier one when zip didn't exist as a function. And like, you know, if we tried to call foo here and it doesn't exist, like now we've got an error and it still tells us exactly where it went wrong, line 5. But there's nothing on this line that screams to us about what went wrong. You sort of have to look at that and go, wait, why is this what's wrong? I'm not throwing, oh, maybe foo doesn't exist, right? And so that's some of the other stuff that happens when you're dealing with these errors. You could probably have a whole session on just how to work with errors and how to use them effectively. It's really hard to write a bunch of code that creates errors that you can debug. It is accessible, but
So just to clarify too. So like I guess throwing errors is super important when you're doing test-driven development. Like doing this, like are you meaning like actually like how would we use this for like going through code? We just like throw it in there to see like if this item would work.
yeah, normally, now again, we're doing this by hand so that you guys, first off, I just want you to get more practice writing things out without having something to do it for you. A lot of times, if you're doing test-driven development, first your tests will be living in a separate file, for example, and they will not necessarily throw an error directly because you're using a library that will sort of do that for you. And then it will, a lot of times it'll run through all of your tests and tell you which ones failed out of all of your tests and which ones passed. So in our case right now, it's going to boot out when the first one fails. We could do some complex logic around it to make that easier, but I'm just not worried about that right now. So I might see if I should have probably pulled down like a project that does some of that, but I could pull something down and just show you what that looks like later, or even just show you even online. But it's a little bit of a different workflow. And then a lot of times what you'll be doing is actually, if you're doing this in a job or you're doing this on a project, is you'll have a program that's continually monitoring all of your test files and your other code. And anytime those get saved and changed, it'll rerun your tests and you'll immediately see like a green check or a red check, basically like, nope, you've got a failing test, or yes, everything's good. And so you're not even having to necessarily run stuff manually. You've got a little bit of a watch program that's saying stuff changed, run it, run it, run it, run it, run it.
So it's kind of like a creature and validator. We've got HTML and CSS validators online. Public files will be like, your errors are at, it does it itself.
Yeah. I mean, yeah, you're writing all this stuff, but yeah, and then you'll just have this running in the background while you're doing development so that you know that everything's still passing. Like that's a pretty common workflow. And sometimes you don't because they're too expensive, and so you still run them manually. But sometimes you're just running them all the time, depending on what the project is. A lot of good questions, a lot of good comments there. Anything else on that? All right. So following with our trivial bits here, we've got a test. Zip function should return an array, but it didn't. And we could if we want. Well, before we do anything else, how can we get this test to pass? Minimal amount of code. Return test result? We just need to return an empty array. Very, very trivial. We can literally just return an empty array and we finish running our tests. Yay, we're all good. Does that make sense? I know you're like, we didn't really get much from that. And if we want to, we could always put some extra stuff here, right? Like now okay, we've got it passing, let's add some extra stuff. In fact, what I'm gonna do here, just for the sake of changing this workflow a little bit, I'm also going to make a test name variable. I'm just making some of this up as I go right now because I've never written my own testing library, so making some of this up so that we can reuse things. Zip should return an array, and now I'm going to throw an error using that same thing so I can be lazy and reuse it and not type it out repeatedly. So we failed this test. And then I'm going to console log when it's successful. Why not? Let's check that. Let's see if it works. All right. We're passing. We're logging this thing. We're not throwing our error. And now we can sort of reuse this name. We've got a little test name, test result bit. I don't know. It seems like it's a little nicer to do it that way, maybe. All right. You feeling comfortable with what we've got so far here? Any questions? So let's try and tackle, this one's actually a big step. We could probably take a much smaller step than this. Let's do this one first. So this one should return a single array containing all items from 2 equal length arrays. Let's make it even simpler, right? Test name is zip should return single array containing each item from 2 single character arrays or single item arrays. A little long, a little wordy, but whatever. All right, so now what we're gonna do is follow this same sort of pattern we've been doing. I'm gonna write a test that's going to call zip. So I want to store my test results from calling it. And I'm going to call zip. And I want to pass in just 2 single item arrays. 1 and 2. And now we've got a little bit of a challenge. We've got to write some sort of validation here, right? And I'm going to do this in just the dumbest way possible right now. So if test result at position 0 does not equal 1, or test result at position 1 does not equal 2, maybe I'm going to change these because 1 and 2 will get confusing with the index stuff. I think it'll be a little clearer if I use letters. In that case, I want to do the same thing I did before, right? I want to throw an error. Otherwise, I want to pass. So I'll just, good lazy programmer, going to cut and paste my stuff from before. Got something very minimal. I don't know if there's any bugs in this. Might be, but now I should have a failing test. Oh, look, my error didn't work. Maybe I can't use string interpolation inside of the error. Well, I used it in the console log, but I never verified. That goes back to what I was saying, right? Make sure your stuff fails. Maybe this doesn't work. Let me see. Let's see if this will, let's see if it'll work if I just change it to do it the old-fashioned way. All right, let's see about that. What's wrong? Oh no, it's correct. Sorry, it's telling me the line, and there's the message. Is it working right before, and I just didn't notice? Let me try it. I don't think it was. I think it was screwing up. No, it did. Okay, it did string interpolation. Failed test. I was reading this line. That's just telling you the line. See, look at that. I got completely lost reading it. All right, so we've got our test failing, as expected. So now we can write the code to get this passing, right? And I'm not going to make you guys try and figure out how to write all this code. I'll try and do this code. I'll just give you some numbers. And I know it's, again, you're going to be like, that is not what you would actually do, but this is the way I'm going to write it, because it's sort of the minimal amount of code that I could write to make this pass. I'm literally just taking the first element from each one of them and putting them into the slots in my new array. Let's see if that works. Oh, I can't reference them inside of it this way. Is that right? Oh, cannot read property 0 of undefined. Oh, you see what's wrong now? Where's my error at? It's up here, but this is where the call stack comes in handy. If we go down and look at this call stack, we'll see that it says the error is at line 217, but then it also says the error is actually at line 6. Do you see what's going on at line 6? What? It's calling the function, but it's not calling it with arguments, right? And so now we've got a problem. One of our earlier tests is failing with the code that we did to try and get this other test to pass, right? Now, there's things we can do here, but typically the pattern you would take is either refactoring your code, but another one is make this test work, at least see if it'll work. And this may still cause it to fail because it's still going to say cannot read property 0, except, yep, now we're down at line 11. So you have to, that's what that call stack is about. What's actually saying is line 2 is what failed right here, but the line that called that was down here at line 11. Sure enough, this one wasn't calling it with any arrays, so let me try and fix that.
Here's the second number after the column. Just I want to make sure everyone understands that.
Yeah, it is. It's not always that useful because of the way that it works, but the second number is the column, so it's saying 217. So if you look at the very bottom of my screen here, you can actually see the column number that we're at right down here for anyone online. I don't think I can easily move that up. But you can see that it's saying the problem was here at this, what we tried to pass into the zip function. or when we invoked it is really what it's saying. Oh, you invoked it, and that's where my problem was. So
Well, it's actually saying 11, 14, so it needs to be.
11, yeah, it's, I mean, it's the invocation of this is the problem, right? So, and this is really stupid. I'm going to do this just to show you that you would still fail, because this should still assign the results of zip into test result. And what we should see now is it says it fails farther, like 1122, which should be where that bit of code is, because this bit of code will all run correctly. But it's this that's going to actually fail. That was,
The basic syntax is the file name, file number.
yep. And it's the full path to the file that it's going to show you.
Out of curiosity, what happens when will it take your control?
Yeah, it jumps you to that bit in the code. This is in Visual Studio Code, right? Now, that doesn't mean that it'll work elsewhere. Visual Studio Code is smart enough to help you out with that. You might get the same behavior in Cloud 9, maybe, but I'm doubting it. So we can fix that still, right? We know we have to pass in some arguments now. We did that. And it says we're passing our tests. All right, so now is the time where we put on that refactor hat a little bit, potentially. And we might say, I really hate the way that I did this, but I know my tests are passing. I know I can make them fail correctly. Maybe you want to change the way that we're putting these items into this list. So normally I would probably do that at this point in time. I am not going to right now, just because I want other tests to fail easily. And if I do some of the refactoring I would do, it would make future tests pass before I get to them. So I want to show you guys some more failing tests, but just continuing this process. All right, so now we can have this one, right? These two equal length ones. 1, 2, AB. And we can say, let's sort of copy this whole workflow again. And I will admit, tests tend to be a little more repetitive than your actual code. You tend to have, I don't love that aspect of test-driven development of writing tests, that there's more copying and pasting involved. I think a lot about how we could solve that as a programmer, but I don't know how to get around all of that yet. So there is a bit more copying and pasting because you're usually following the same sort of patterns. Each item from 2 equal length arrays, right? So now we're going to make this one a little more complex. We're going to have A and C and B and D. And now we're going to say, all right, I'm going to write it out the same way still. And I'm actually going to split this code up onto separate lines just so that it's a little easier to read. And yes, you can do this. Again, we are going to refactor this in a moment, so I wouldn't worry about the fact that this is really ugly in brute force. And in fact, when you're doing this type of stuff, I would suggest you probably do something like this anyways, right? Is do it ugly in brute force and then see where you get from there. All right, so let's see what happens. We should fail. Let's check where we failed. Line 32, this is what failed. And that's because we're only dealing with the first 2 cases, right? We're only copying the first, in our zip, we're just doing this right now, right? All right, that's really dumb. But again, I'm going to continue following this dumb approach at first, and then we'll come back and fix this. We're going to now say, oh, array 1, the first item from that, and array 2, the first item from it. I'm literally just hard coding these things in back and forth. Who feels like that's just the wrong approach? Like, oh, this hard coding just feels wrong right now. I mean, most people should, at least at some level, feel like it's wrong, right? But that's part of the challenge of trying some of this stuff out, is you're going to do some patterns at first that are going to feel almost wrong when you're writing some of the tests initially, or even writing the code. But the goal is to make sure that you can get test to fail, get test to pass, and then you can go back and refactor. Normally, you still wouldn't do it this badly. This is still a little bit for exercise to show you it this bad. But the point is, you shouldn't be worried about getting it like optimized. Oh, I could have written this using a map versus a for loop. Oh, I could have done this other thing. None of that matters when you're first trying to get your code to pass. Let me ask another question. Does this feel similar to the same approach I've been using for development up till now, where we're sort of building our stuff up small piece by small piece, right? What? I'm building them up in a little bit different pieces, but it's still tiny piece by tiny piece, right? And that's exactly what I'm getting at. I think whether you like this type of approach or whether you like, just small, like I'm writing out the functions type thing, the most important aspect is learning how to work in these really tiny pieces of code. So, okay, I've written this really brute force bit, all of my test pass. Now, for the first time, I'm going to go back and do this refactor portion where I'm like, oh, I think my tests are really ugly. My code's really ugly. Can I fix some of this? All right, I don't want to hard code things like this. I want to step through my arrays. So let me see how I can fix this. I'm going to leave that line there, sort of commented out, just as a reference to what I had. I'll give you guys a second, see if anyone has an idea before I tackle writing it. I've got some ideas that I know will still have bugs. So, any ideas? All right, let's do something really simple. Let's say for variable index, we're going to start at 0, and we want it to be less than the length of the first array, and then we want to increment it each time. What am I missing? Oh, I need to have something up here, right? Zipped array. So we're going to create a new zipped array. And then what we're going to do is we want to take the one from the first array and push it in. If you remember, push is the method that you use to shove something on the end of an array. So we're going to take an item from the first array at the current index, and then we're going to take an item from the second array at the current index and just push these on. Pop, pop, pop. And then let's try and return this. And let's see what happens. Oh, did I screw something up here? Oh, this isn't I, this is index. I fell back to bad programmer habits there. All right, we're passing our tests. Cool, so we made a small change, and here's some of the stuff that we gained by having those tests. We've got a lot of confidence that we didn't put a new bug in our code around any of those test cases. we can say, oh, we didn't break any of the functionality that we're already checking with the stuff that we just changed, right? And we did that without having to run through a whole bunch of stuff manually again, because we've got tests that already run for us. That's one of the benefits that you get. You gain this strong confidence in rewriting your code and testing something out when you've got tests, because you're not afraid to try a new design pattern, to try a new approach, because you know, oh, I already have something that's going to tell me if I did something wrong. I can always go back to what I had, and it's covered. I'm not going to accidentally break any of that stuff that I'm already checking. Feeling good? Yeah? All right, I don't need this anymore. Now, again, I haven't been doing this today, but typically I would probably also be doing some commits with these in my workflow. So I would be committing the changes when I've got stuff passing most of the time. Like, all right, passing my tests, I can zip 2 equal length arrays, just so that I have those snapshots captured. So let's see what our next one is. What's our next thing? And we may not end up successfully being able to fail all of these with the way that we're writing the code. That may happen. When the first array is longer than the second array, return the correct zipped array that contains all elements from the second array. All right, so when we have 1 and 2 and A, return 1 and A. Well, let's just use number or letters again. I think that's a little easier. So, oh wait, you know what? I want to clean up this stuff before I write another test, because this is really ugly too, right? Is checking each one of these. I wonder if there's a way. Let me see if I can do something simpler. I'm going to check here. I don't know if I've got a nice little tool here, but I'm going to look from the properties or the methods on an array to see if this will work. So I'm going to do a quick Google search, because there might be something easier than me writing something out. That's a nice little hack. What? Where's some of those scary underscores? Yeah, right here. See? Oh, don't do that stuff. It scares me. All right, here's a hack. And this only works because we're assuming that, remember, one of our assumptions was we're only working with like strings or other basic things in our array, right? We're not going to work with objects. We're going to work with some very simple things like numbers or strings. So I'm going to do something, a little bit of a hack here. Don't worry too much about it. But if you were doing this, you know, you might do something like this as well. And the idea is you can join all of the characters in an array. Here, I'll show you real fast. Actually, we used this in the last class. We did a join where we had a join character, which was a space, right? So we can do the same thing, and then we can do string comparison, and string comparison is easy. So we're sort of cheating. So what I'm going to do is create another variable up here, expected result. And for these ones that I care about stuff, I'm going to create an expected result, or assign this to something as well. And because I know I'm going to stringify these, I'm just going to already start it off that way. And then here's what I'm going to do for my test. I'm going to say that if test result join with a comma equals expected result. Let's see if that works. I think it will. Might have failed. Looks like it did. All right. So I'm going to, for the sake of helping me out here, I'm going to console log this just to see what's wrong. A little live debugging here. Come on. At AB, expected AB.
So typo there, so it's good.
Maybe that should be good, but I'm gonna try. Let me see here. Let me go check what this join method does real fast. A string returns a string with all elements joined. All right. Let me see what could be wrong. Test result.
Because expected results of string instead of,
No, because this should become a string too. So let me check. Let me console log here real fast. Well, first off, okay, that's the same. I'm checking for typos. I'm gonna do something weird here. Just to see if it could be. That shouldn't be the cause of the problem. I'm gonna flip this. Oh, God, dang it. What do I have wrong? I know what I have wrong. I changed my statements. I want them to know if they're not equal, it's an error. If they're equal, it's correct. Oh, man. Look at that. Burned myself. All right. Hey, we're passing. So now I can continue with that same pattern, right? I can take this whole guy and simplify it and say my expected result is A, B, C, D. I can get rid of all of this ugly logic here and just replace it with that. And that should still be passing. This is, again, another time where I would do a commit, like, oh, I changed my tests, refactored them a little bit, they're good to go. But now we've got a much easier way to do our testing of this stuff, right? We don't have to manually write them out. But you notice I didn't focus on trying to solve that before I got the initial tests going. I did something really simple for my test and then did this. You got a quizzical look on your face. Yeah.
So I was just wondering what happened if you tested, like, use numbers instead of.
It should work. We'll test it with this next one. Why not? I was avoiding numbers but I'll use large numbers. That way they won't be confusing. So let's put another one in now, right? Zip should return a single array containing each item. What did we have over here, right? I'm literally going to like steal this, even though it's crazy long. All right. So we can use numbers. Why not test something like that? 42 and 100, and this can be like prime numbers like 13. And what we would expect is, I think this would still work. So what we would expect is 42 and 13, right? We zip these things up. Maybe we'll find a problem with the little shortcut that we're using to test things. All right, so we have a failure. Now, a lot of times we don't have this going on in ours, but a lot of times also in your testing library, and this is just because it's gonna add more boilerplate, you won't just see failed test, you'll get to see like what went wrong when your tests fail usually. So usually you'll see something like, I'm going to change this error a little bit. And let me see if this will work. I'm going to put a new line and then put expected test result.join to equal my expected results. Let's see if this works. That /n, by the way, don't worry too much about it. That's just programmer speak for a new line. That's how you put new lines into output. Let's see if this worked. Oh, cool. It did tell me what. Expected 42, 13, 100, comma, to equal 42, 13. All right. So our zip function isn't working right because it didn't give us back what we expected. Can anybody tell what's wrong there? There's a very subtle hint there. First off, we're getting the second one from this first array. But if that's happening, then we must be trying to get, because if we go look at our actual zip function, if we're getting the second one from our first array, we must be trying to get a second one from our second array, but it doesn't exist. What happens when you try to reference an element in an array that's not there? What's that? It's undefined, yep. We can see that. Oops, let me first test that, right? Like if I try and access array at 0, it works. If I try and access array at 5, I get back undefined. So what's actually happening is it's trying to, that's where that extra comma came from. Oh, that's not my last command ran anymore. This comma is actually comma and it's trying to put undefined there. But undefined turned into a string is an empty string, which is why it doesn't actually put anything there. So, all right, so we know we've got a bug in our code. Yay. This is working, right? This is our workflow. So now we know we have to change the logic here somehow. We've got a problem because, anyone see why that's happening? Because we're only checking against the length of the first array, right? But we only want to zip up to the length of the shortest array. And in this case, the first array is longer than the second array. All right. So we can fix it. Not hard. We can do a var shortest length. We're gonna maybe, I don't know, start it at 0 even. And then we could do like, this is very, you know, hands-on. There's probably a much simpler way to do it, but R1 dot length is greater than array 2 dot length. Then we can just, the shortest length is array 2 dot length. Otherwise, array 1 dot length. Oops, sorry. I need to assign it. Then we just change this to say, well, index is less than our shortest length.
That's a problem.
It probably is.
It's only one to the other. It's not-
Sorry.
it's only comparing one to, I don't know how to explain it. Like it's checking,
Oh, I have this backwards.
like it's checking if one is greater than two, but it's not checking if two is greater than one. Yeah.
Well, you don't really, these are some of the tricks that you learn after you've written a lot of stuff. You don't have to check if 2 is greater than 1 because if you can go through all 3 cases that can exist. If 1 is longer, then we care about it. If they're the same, it doesn't matter which one we take because it'll be the same value. And if 2 is longer, then 1 won't be longer, so the else condition works. So there's sort of a little bit of like the else catches both of the other possible situations. Some of that you just learn after you've done a ton of coding.
And actually,
Did I? Oh, I'm doing the shortest length, that's right. Because I want to get the one that's shorter. See, this is the problem with conditions. It can be very misleading. All right, let's see. Yay, we're passing. So we did a little bit of a change, we've got it passing, right? Does anybody have a simpler way to write this? There's tons of simpler ways to do this. There is, yeah. That's probably the easiest, right? So let's do that. Let's go look it up because as a good developer, I don't remember anything like that. But I do actually remember, is there a min? Oh, math.min returns the lowest valued number passed into it. So if you pass in 2, 3, and 1, you get back 1. -2, -3, -1, you get back -3. Awesome. So math.min, R1.length, R2.length. So we can refactor now that we've got something passing. We feel comfortable refactoring. Yep, we're still passing. All right, we know we didn't break anything with that change. And our code's a lot cleaner. But you didn't have to feel like you had to do it that way, right? If you're intimidated, you're like, I don't know how to use this math min, but I should use it. Yeah, do it the brute force way first. And then you can come back and try out the math min, and then you can go, oh, okay, I get what that's doing. I understand. We can't concatenate them because concatenation is different than zipping. Zipping is taking one item out of each array and putting it in. Concatenation is taking one whole array. Imagine, I like to think about train cars when I think of arrays. I don't know why. For me, cars on trains are what I think of, right? Concatenation is like you've got a whole train and it backs up and connects to another train and pulls off. And zipping would be like you've got 2 trains coming from 2 different tracks, or you're pushing carts on from 2 different tracks, and one goes on and then they connect one from over here and then they connect one from over here. So zipping and concatenation accomplish 2 different things. Yeah, there is a concatenation though. We just don't have a zip. Other languages have zip, and you can do some really weird, crazy, powerful things with zip in code, but JavaScript just doesn't have it built in. All right, I think we've had some good conversation about this. Any other questions on where we're at? So let me go back here. Let's take a quick glance at some of these. All right, we've got those passing. When the first array is shorter than the second array, return the correct zipped array that contains all elements from the first array. Oh, here's a good set of examples too. So this one used hello world, and then 3, 5, 7, 11, and 13. I'm going to write this one out. Oh, I'm going to copy that line first real fast. Yeah, copy paste. But all good developers do. No, they don't. All right. So now the first array was shorter in this case, right? And it was like, hello world. I don't remember what was in the second one. It was all primes, 3, 5, 7, 11, 13, right? And the output should be hello 3, world 5. Well, let's see. Now, this is one of those cases where, did I mess up? No. What the? You go away. I don't want to see all my keyboard shortcuts. That's cool though. This is one of those cases where the test is passing because our code is actually already accomplishing what we wanted here. We didn't have to do anything new. This is also one of those ones where, you know, I said it can be useful to force your code your test to fail, and it seems really stupid, but honestly, I might do something as simple as this, even though it's really brute force real fast. And yet, the challenge is I would need to make just that one test fail. I don't know how to make just that one test fail in this case versus the other ones. So I guess I'm not going to do that, but normally you would want to make sure that the test fails as well. I'm thinking, I really don't know how to do that very easily in this specific context. But we've got another test, and hey, our code already is passing it.
You make the mistake to make earlier.
Yeah. Yeah, we could do, like if we did that, you know, if I switched, I guess I could fix it by, or cause that one to fail and the other ones to pass by doing array2.length here. And I think everything else will still pass and just that one will fail. And that just happens to be because I wrote all these tests right now and I know how they work.
You also get to fail by putting in wrong expected.
You could get it to fail by putting in the wrong expected results, which is also sometimes a way to do that, especially if what you want to do is see that it was correct.
Like if you did world 3 color 5 instead, just
Right, like if I did like 7 here. And so, you know, that's a good point. That's something that I might do as well if I can't get it another way. And the reason isn't because I'm just trying to cause the failure, but the reason is because I know it's easy to change my expected results. And then, this is a little bit of a hack, it almost always tells you what it actually gave you. And so then you can sort of cheat and go, oh yeah, I did get back what should have been there, and here's the failure. And so it let me cheat and see what I actually got back. Whereas a lot of times when your test pass, you don't want a whole bunch of clutter in your output, so you don't see, like, here's what you got back for this test. You just usually see, oh, that test passed. So let's see what we have. This one would work. I'm gonna see if any more of these would fail off the top of my head. This one should work. We already know this is working because we have that in one of our other ones. Yeah, here's one that we haven't tested, right? Throws an error when the first parameter is not an array, throws an error when the second parameter is not an array. Those are ones we could write tests for as well. Those would be a little bit different tests because we want it to throw an error. And we're gonna wanna know what the error is. So those tests end up being pretty interesting. I'll write them here for you guys, but it's probably not something you would write immediately. Or in anything that you're doing right now. So let me Let me show you what that would look like, because it'll give you another little bit of an introduction to some more error handling type logic. Throws an error when the first parameter is not an array. All right, so I'm going to have the first parameter be, and this is interesting because this is actually not going to fail, I think. Well, it might because of this, right? Expected results. Let's just see what happens. This will be intriguing. I haven't finished writing this test yet, but I'll show you how you actually would in a second. So that didn't fail in the way you might have expected, because if you look, it says it expected H3, E5, L7, L11, O13 to equal this. So it actually did zip our string into our other array. Anyone realize why that works? If we look at our zip function, all of those operations that we're doing work for strings. Strings have a length, and you can reference the individual characters in a string using indexing or square brackets. So all of this logic here works for a string as well. So we could actually, if we didn't want this to just work with arrays, we could have this work with like strings or something else. But part of our rule is we want to only work with arrays. All right. So how am I going to do that? How am I going to verify that this works? In this case, I don't actually have expected results like this. I have to write this very differently than I would otherwise. I need to put this in what's known as a try-catch block. This is what I was saying before, is this is how you deal with errors in your code and keep your code running afterwards. So what you do is you put some bit of logic that might cause an error in a try block, and then right afterwards you put a catch block that catches the error, and you usually want to I'm going to actually pull up the reference real fast just to make sure I get it correct. All right, so you just say, let me see here. Catch, and then you give it the error. You can assign it to any variable name that you declare in there. It's almost like a function. But I think you can also check for a specific type of error. Let me see. Oh man, can I not? Oh, there we go, yeah. So you could check that it's of a specific type of error. So I'm going to catch the error right now. And this is just me knowing how I want to write this. I think I can get this to work correctly. If I can't, I'll change it, but I want it to be a type error. I only want to catch. Is that syntax wrong? Oh, E if, okay. Oh my gosh. Not gonna work. Let me double check. Oh, you have to have a, do I have to? No. Let me see. Try something, catch E if E instance of.
I think you did write something in the code back.
I mean, maybe. I don't think so. I'm just going to leave it as E right now. And then I'm going to log it for my own sake so I can see what it is.
You don't want to say that's
I do, actually. It's sort of weird here. This is going to be a really hard test to write without a tool because I want it to throw an error when the first parameter is not an array. So this is like the correct case. And then what I'm going to do in this case, just to help me write this specific test, I'm going to do something weird. I'm going to say, this is what I'm going to do. I'm going to change this a little bit. I'm just going to log this in here. And now I'm going to have my if didn't and change that to did throw error because it'll read a little more like English here. So if we didn't throw an error, then we want to throw an error here saying that it didn't do what we wanted. And if it did throw an error, then we want to do this other bit here. So this is a little bit of jumping through hoops, right? Because we want to have an error when we pass in something that's not an array. We want to catch it, and oh, you know what I'm missing here is I need to change this value. I need to change did throw error and set that to true. So there's probably a bug in this because this is some weird logic, some weird code. Well, let's see. All right, we failed the test, throws an error when the first parameter is not an array. So let's see here. Sure enough, it tells us there's a problem at line like 74. Oh, so it looks like that works. And we're not throwing the error that we expect, right? So now we can come up here and try and put in some logic to throw the error. If not array.isArray for array 1, we're going to throw an error. So now I've put the code in. Let's see if I get my stuff to pass. I'm passing by throwing an error. But that error isn't crashing my code because I'm catching it in here. Yeah, you will, because that's because I'm still logging it. That's my log. From right here, or hold on. That's my log right here. And that was just so I could see the error type. I'm going to go back up here and see if I can.
Use a try catch to catch executes.
The catch execute.
And the try is successful.
No, the catch executes only when there was an error, but I hit this. I actually threw an error, so the catch executed. And then it kept running the code because I caught the error. This is the case where I actually want there to be an error. And so I'm catching an error, and that means it was successful. So let me see. Oh, I did throw a type error. All right, I'm going to try this code down here to make it more specific. Let's see if I can get this working when it was complaining before. Catch E, if E instance of type error. I'm gonna see if this works, but it might not. I'm guessing then. Oh, there we go. Look, I need to read. This functionality is not part of the ECMAScript specification. It has been removed in Firefox 59. Oh, here's what it is. It does say all I should need to do is instance of. Oh, okay, never mind. I can't have it in the catch. Got it. I have to do this. I see the code now. So if I only want to catch this one type of error, I have to put it in here as an extra conditional. If instance of type error. So that's good. All right, I threw an error I expected. And then what I'm going to do here, actually, as weird as it is I'm going to be like throw E, which is basically saying, because catch was saying, all right, I've dealt with the error, and here I'm saying, oh crap. Oh wait, hold on, I don't want to do that. I want to put this in an else. Else, throw E. So here I want to say, all right, if it's the error I expected, deal with it. Otherwise, throw it again so somebody else has to deal with it somewhere. I still want this to be an error, right?
So, answer that to
There was a lot there, yeah.
So I think there are two major things I saw. First one, major distinction between what we just did previously. Jared threw an error inside the function itself. Previously the tests were checking to see whether the output was what we expect. And now we're writing in an error checking method inside the function to make sure that the user inputs the correct type of argument. So that's an important distinction, and something you really want to do when you're writing functions is that you definitely don't want someone passing in the wrong type. And usually you'll have like documentation that will, hopefully you'll document your code well enough that it should be obvious what should happen. But just in case, you also don't want someone to. That's the first thing. The second one is the try and catch block. And maybe Jared might be able to explain the flow of what happens in that.
Yeah, this is, again, we haven't talked about it too much. I would suggest you go read about it. So spend some time reading on error control logic, because it's sort of like a circumvention of all of your normal code flow. And what you do with the try catch is that's where you think maybe something's going to go wrong. So usually if you're writing a big complex application, your tries are going to be on the outskirts of your application where, say, user input's coming in, because that's what could cause a bug. Your inside code, you should know that you're passing the right variables around. But out on the edge, a user may try and pass something in wrong and you want to guard against it. And so what you'll do is you'll have some try logic around there so that if something goes wrong and an error gets thrown, you can be notified about it. And the catch is how you deal with errors. So that's sort of your like fallback of, oh yeah, I expected this type of error. Or maybe you want to do something specific. Maybe, I'm trying to think of a good example.
So I do this a lot. So the reason I use try catch is because you normally when you have an error in your code, the code stops running. And oftentimes that's exactly what you want to have happen. There's an error you don't want to keep going. However, there can be circumstances where there's an error, but you actually do want it to continue running. You don't want it to just completely stop. So for example, like when I'm scraping data from the web, I have like, let's say 1,000 companies that I'm going to wherever to get data on. And most of the companies have pages with data on them. And so for 99% of the companies in my list, it's going to run perfectly, there's not going to be any problem. For a small subset of those companies, however, the page will either not exist or it will be completely blank. But when the code runs into one of those problematic companies, I don't want it to break, have it stop running. Because like, let's say, you know, I want to set it running, things for the whole 1,000 companies is going to take an hour to run. And there's a problem at company number 57. Well, I don't want it to stop at 57 and then miss the last like 900 and whatever companies. I want it to skip over that problematic company and keep running until the end. So that's why we use a try catch. So I would say try, and then in English I would have a function like scrape data from web, and then in my catch block I would say, okay, if that function through here, then spit out an error message, but keep on going, keep continuing on that iteration. So that's the typical example in my day-to-day work that I would use.
Yeah, that's a fantastic example of it. Is, you know, scraping a bunch of websites and then you don't want one of them to cause a failure that blows everything up. I mean, yeah, I've got the same sort of example now that I'm thinking about it, right? Like we've got some processes that go through and put together data from a bunch of sources, and this build runs, you know, once a week and takes a day to run. And we don't want that build to fail if one of those bits of data is screwy. We want it to just skip over that, record it, and keep running so that we can deal with that later, versus stopping a build after it's run for half a day and go, shoot, we have to start it up again, fix the data and start it up again, right? And so it's really nice to have a try catch around that says, oh, this thing blew up. We know that we can just sort of skip over all that and continue, and we'll deal with that later. Those are the really important contexts for it. This isn't something that you would want to use just to not have errors in your code in other places, because you still want those errors to surface.
So the block and catch section basically anomalies having run the section.
Yes, yeah.
Okay.
And that's the only way to catch an error, is to have a, like in JavaScript, different languages have different error handling mechanisms. In JavaScript, if you want to stop the error from crashing stuff, you have to have something wrapped in a try catch, because otherwise you've got nothing. That's the only way to like stop an error from propagating up and blowing up the program.
Sometimes I'll just have like, I don't even put anything inside the catch. In that kind of circumstance, I would have like a data table, and I would know if the row for a given company were all NAs, then I would know that there was an error there, and I don't need to have an error message. But you would only do that in the case of, in that sort of case where you have some other way of knowing whether or not you're, normally you probably would have to know log data.
Right. Yeah. All right. I mean, that's a great conversation. And I don't think we ever actually covered error messages and error handling before. It's not something that you usually are writing your own stuff in. It's one of those things that is you'll encounter and you have to deal with, but a lot of times you're not writing your own errors to throw in your code.
We have a request from Slack to
Ooh, an assignment with try catch. Yeah, we can do that. Let me, hold on. There we go. Look, I had one note open to exercises to give out anyways. Oh wait, I've got this stuff over here. All right. I mean, I don't want to keep us to the very edge here. We could write one more if we want, and I'll do that real fast, which is just the mirror of this one. And that's, we want to throw an error when the second parameter is not an array. So here we've got all this nice logic, blah, blah, blah. All right, I'm gonna copy all this stuff. Oops, went too far. Very slow. Do it very slowly. Can I? Oh, it didn't work. Something just went screwy. Oh, hold on. I hate undo and redoing stuff on a Mac because they work really weird. All right, I'm just gonna copy all this. Again, because I'm a proper lazy programmer. And I would probably clean up the way I did this. If I was ever writing my own test library, I wouldn't be copying and pasting stuff all over the place this way. I would have made some other functions that help me out here. But in this case, I'm just gonna sort of flip these. All right, my second parameter should be not an array. First parameter can be an array. I want the exact same logic. I want it to throw an error. Come down here, let's see what happens. We should fail as expected because we don't have any logic in our code to check that. So we can just put another one here. So if either one of these isn't an array, we want to throw that same error. Let's test it. And we're passing our tests. At that point, I mean, we're already testing this one too. So we've pretty much, I mean, got a set of test suites that verify that everything works. Now, one of the cool things is if you wanted to try and write this zip function any other way, you're like, oh, I want to experiment with other ways to write this and see if they work. You've got to also now have a set of tests that will tell you if it works every time that you do this. And this test-driven development approach, just reiterating, if you remember all of the REPL IT stuff that we did where you guys were running your code and it was hitting some tests, that's exactly what I was doing. Is I was writing tests against the expected behavior, and they were failing and giving you error messages in this same sort of fashion, except I was using a library that makes it a little bit easier to do. And this is part of, I can't say every team does it, but this is a very common pattern in the field. Some of my old software development teams didn't do it. We definitely practice it on the team I'm on now, and I am a really big proponent of having stuff like this, if for nothing else, to help you think about how to break your code up while you're developing. But it also just gives a lot of reassurances if you say like, oh, we need to go rewrite this portion of the code. Hopefully you've got a set of tests that help explain what the behavior is you want. All right, any other questions on this? So the goal here as well, let me check what we had here. Some of these are really a challenge. I might just try and think of a different one instead. This one shouldn't be too bad though. So what I would suggest is hopefully you've written test cases, like thought of what the test cases would be. So take that idea, the test cases that hopefully you've been working on, and try and write some actual tests for the palindrome function. And I know you're not doing it. If you want to, you can write your own palindrome function as well while you're doing this, right? Write tests, write a palindrome if you haven't already written it. But try and write some tests for it just to test different possible cases. Think about the edge cases. And I'll definitely, I don't know how easy it'll be to screw that one up and write stuff bad. But if not that, I'll at least get another one that I think is good, like the zip one. I think is a great example where I'll have you guys write test cases, and I will provide the function, and then hopefully you'll be able to tell me where stuff is failing. Now, we'll probably hold off on that until we're using a testing library, so you'll be able to see all of the failing tests at once. But that's definitely something that I want you to get some practice with. It's a great way to practice coding, and it's also a great way to think about all of the cases that you need to account for in any given function. And on Saturday, I'll double check. I'll probably send something out, but let me know if people plan on being here because I will be happy to come here. But again, it'll probably just be a hands-on, helping people out with any issues that they have or any questions, or you want to work through some problems or you want to talk about a topic. It probably won't even be streamed because a good number of people are going to be at the hackathon, the RTP hackathon instead. So I don't want them to miss something, but I still want to provide people with the opportunity to get something out of class on Saturday.
They're meeting here.
They're meeting at the Frontier, I think,
Yeah.
for the hackathon.
But, you know,
We can either, would people, who's going to actually be available on Saturday? Like, okay, would people rather meet here in person? I mean, I'm fine with it either way. I have no problem coming in. It's-
I'm available.
all right, yeah, I mean, I can come in and then it could just be sort of hands-on, working through any questions you have. So think about, it's like what areas you'd love to talk about more. No, not for Saturday. It probably wouldn't be very effective with that sort of class, so. All right, give me just one moment. I want to end my stream. Sorry. All right, I'll talk to everyone later who was watching the stream. And everyone goes to the hackathon. Good luck. Have fun. And see you guys next Tuesday for sure.